Apply elimination to the 3 by 4 augmented matrix. How do you know the system has no solution? Change the last number 6 so that there's a solution. Okay, so so let's take the augmented matrix first. AB, this is B here, column vector B. So this is 1 2 3 1 2 3 4 2 and 3 5 7 6. Okay, so the first elimination we need to do is to make this guy a 0 here. So this would be minus 2r1 plus minus 2r1 plus r2, and I could apply this on the identity matrix, and if I apply this on the identity matrix, I will get E1 or E12. So this would be 0 0 1. Okay, let me just so I don't have to rewrite it, I'll just do it on this and change the second row. So minus 2 times 1 minus 2 plus 0, this becomes a minus 2. This remains the same, this remains the same. So this is my E12. And now I will operate on my augmented matrix with this. So I will get a new augmented matrix. So now
how is this different from
A1,
what?
not very different. But I have a feeling you still didn't get it. Okay, so my A1 B1 will be E12 times my augmented matrix AB, and I'll just do, so basically I'm gonna multiply.
So basically every matrix that you when you manipulate a row in it,
I'm gonna multiply this guy by this is a 3 by 3 and this is a 3 by 4. Yeah, I'm gonna multiply this guy times this guy. So I don't want to rewrite it because I showed you which ones I'm doing. So the red one first, then the blue. And if I do that on the calculator, I will get one moment here while I do it. So here we get, when I multiplied those using Mathematica, 1 2 3 1 0 minus 1 minus 2 0 3 5 7 6. Okay, then comes the second elimination step. So for the second elimination step, I will do on the augmented matrix is 3 times negative 3 times row 1, negative 3 times row 1 plus row 3, because this will get me a 0 here. Negative 3 plus 3 is 0. So I will operate with that on the identity matrix. So let me take that and use it, or I could just write it minus 3r1 plus r3 so this will get me E2, or before, let me first write it out. So 1 0 0 so the identity matrix. So if I operate by that operation, minus 3r1 plus r3, minus 3r1 plus r3 on the identity matrix, I will get E2. So E2 will be the first two rows aren't going to change, so let me copy and paste this here, or here probably. Yeah. So this will lead me to E2, which is equal to, okay, so minus 3 times 1 minus 3 plus 0 is minus 3. This will stay a 0 and this will be a 1. So this is E, if you want to call it 1, 3 or E2, whatever. Let's just call this E1. E1. Okay, and now I will operate on the result of the augmented matrix with the new augmented matrix. So now my A2 B2 will be E2 times A1 B1, meaning I will multiply this first, I don't want to write them down, times A1 B1, which I got here, times this. And I already did this on Mathematica, and the answer is 1, 2, 3, 1, 0, minus 1, minus 2, 0, 0, minus 1, minus 2, 3. This is a 3 by 4 because we are multiplying a 3 by 3 times a 3 by 4. So we will get a 3 by 4. Okay, sounds good. Now if I'm gonna go for the next elimination step, which is the last elimination step basically, I would have to multiply row 3 by minus 1. So let me write that here. So this is gonna go here. So row 3 by minus 1, and add it, or row, yeah, and add it to row 2. Oh, and speaking of this, by the way, although I wrote minus 3 r1 plus r3 on this first one here, AB, I'm supposed to write it here, but it's the same exact, because those two rows did not change from here to down here. So so maybe I should have just had it here, because row 1 and row 3 did not change. So maybe I was supposed to write it here instead. Yeah, so this changes this guy, but that the math is the same, the numbers are the same, so it didn't matter. I just put it in the wrong place. Okay, so now going back to this last one here, look what happens when I try to do this. When I try to do this, what I get is the same thing. So let me copy and paste this. But instead I'm gonna change row number 2. So if I do that, this stays 0, this becomes 1, minus 1 becomes 0, and look here, the same thing happens. I get 2 minus 2, I get 0, and here I get minus 3 plus row 2, minus 3 plus 0, minus 3. Okay, and you could see the problem here. The problem, we get an equation that says 0 0 1 second this is supposed to happen on row number 3. I apologize. Yeah, this is here. 1 second. This is, I'm trying to make from row 3, so this will be 0 1 0. Yeah, this will be minus row 2 plus row 1 plus row 3, and so I'm supposed to change the third row. So this stays the same, minus 1 minus 2 0, and here I will get 0, I will get 0, I will get minus 2 minus 2, I will get 0, and here I will get 3. And what do I get? I get the last equation. What does it tell me? The last equation tells me that 0 equals 3. That's why the system has no solution. Well, this is a false statement, and the system has no solution. Okay, now to get a solution, now the question goes on to say, change the last number 6 so that there's a solution. You can see that the problem is with this last number here. Had this last number been 0, if this guy had been a 0, 0 equals 0, that means the system would have infinitely many solutions. So this needs to be a 0. Now remember, this wasn't actually a 3. On the first stroke, let's track it from the very beginning. So this was a 6, and on the first elimination it stayed a 6, so nothing happened here. But when I did my elimination step 2, look what happens when I multiplied these two matrices. This minus 3 has to multiply that 1, so you would get minus 3. The 0 here didn't matter, didn't change anything, but then when I went across the 1 times the 6, so 1 times the 6, so that's minus 3 plus 6, that gave me that 3 there. So if I need this to be a 0, that means what should have happened here is when I do this row times column thing, I should get, if this 6 here, if this 6 here that I highlighted was a 3 instead of a 6, if it was a 3, then I would have gotten minus 3 times 1 is minus 3 plus 3 0, which would have put a 0 here, and on my final equation I would have gotten 0 equals 0, and therefore I would have gotten infinitely many solutions, which means 3 on the first matrix has to be replaced, the 6 has to be replaced by a 3 for this to work. So 3 has to take the place of 6. So in other words, my matrix should have been, instead of the 6 here, I would have had a 3 to have a solution. That doesn't.